All right, we've got one property left, and that's listed as property 6 here. 1 through 5 are the ones from the last video. And this one is so special, it's got its own name. It's called the change of base formula. So this one was really important back in the days before we had graphing calculators that could calculate different bases. Some of them still can't, depending on which one you have. But this is also used in equations a lot too. So we're just going to kind of use it a little bit, but when you get more into logarithms, this one comes up pretty important. So what it says is that you can take a log with any base and change it to any other base that you want. And this is a pretty powerful thing because up until now our logarithms had to match for us to be able to do anything. So we can change it to any base we want, and typically what we want to do is we want to change it to something like common log or natural log because that is something that any calculator can evaluate easily. So usually it's used to change to natural log or common log, but you can change it to any other base that you want. So in order to see how this works, what we're going to do is we're going to look at an example with numbers. So let's say we have log base 2 of 5. Log base 2 of 5. Now again, before we couldn't do anything with this because we only knew how to work with this if we could get the bases to match. And I can't rewrite 5 as base 2, at least not easily. Alright, so what we're going to do is we're going to say, okay, this is going to be equal to x, and let's see if we can do something with this. So we know if we have a log equation, we want to change this to exponential. So the base is 2, the exponent is x, so we're going to have 2 to the x is equal to 5. So now we've got an exponential equation. Well, we still can't do anything with this because up until now, all we've known how to do is to get the bases to match, and we still can't. But now we know a little bit more about logarithms, and I can take a log on either side of this as long as the logs match. Okay, because if the exponentials are the same, then the exponents are the same. If the logs are the same, then what's inside is the same. So I can take a logarithm on either side of this. So what I can do is, I can take a natural log on both sides. And that's going to look like this. Now what this does for us is we bring in rule number 5 right here that we just did. Okay, rule number 5 says that an exponent inside the log can be brought down as a coefficient. So we can bring this exponent down, and we're going to have x times ln 2 equals ln 5. So ln 2 is just a number. You can punch that in your calculator. Ln 5 is just a number. You can punch that in your calculator. So now all we have to do is get x by itself. It's x times ln 2. So we're going to divide by ln 2 on both sides. And we get that x is equal to natural log of 5 over natural log of 2. Okay, so this is solving a log equation that we couldn't have solved before. But it also tells us how to convert logarithms that we couldn't have solved before, like this. We can change it to any other logarithm. Okay, I picked the log that I wanted here. We can change it to any other logarithm, and it's going to be log of 5 over log of 2. Okay, and you can punch that in your calculator, and you should get 2.32 for that. Okay, so check and make sure that you can do that. The logarithm's going to pop up parentheses like this. Okay, so make sure that you close that set of parentheses before you start the next one. All right, that means that we can also do something like sorry, I'm trying to read my handwriting. We can do log base 2 of 25. Sorry, I'm having a little trouble reading my own handwriting. Okay, so log base 2 of 25, I wouldn't have been able to do this one before either, but now we know that we can do natural log of 25 over natural log of 2. You should be able to put that in your calculator, and it'll come out to be 4.6. Okay, so check those out in your calculator, make sure that you can get those answers correctly.